We begin our study of finite math with a discussion of financial mathematics in Chapter 3, starting with Section 3.1, Simple Interest. We'll study two different types of interest in this course, simple interest and compound interest. Simple interest we'll just use for short-term investments of less than a year, and for longer-term investments we'll always use compound interest, whether or not we're talking about compound interest for a bank account, for example, or an annuity or a loan. So let's get started. First, the definition of simple interest is mathematically I equals PRT, where I is the interest amount, P is the principal amount or the amount invested, R is the annual simple interest rate written as a decimal. So in problems usually it'll be expressed as a percentage, and you have to write that as a decimal. And then the time T is the time in years. Now what's important about the time in years are a couple things. We'll often see problems where time is expressed in terms of weeks or months or days, and we have to convert that to years. The other thing that's unique about simple interest is that in the financial world, they use, when they're converting number of days to years for the purpose of simple interest, they use 360 days in a year rather than 365. Now this is only for simple interest, and it's just kind of the convention in the financial world to do this, and we'll follow that convention for simple interest. When we get back to compound interest, we'll go back to what everybody knows to be true, that there are 365 days in a year, but for simple interest we'll use the conversion factor of 360 days in a year. So let's do an example. A department store charges 21% for overdue accounts. How much interest will be owed on a $650 account that is 3 months overdue? Okay, so we're trying to find the interest amount, and we essentially have invested $650. We have a balance of $650 on this account. The time, it's 3 months overdue, and the interest rate is 21%. Okay, so in terms of our I equals PRT formula, we are given that P is $650, R is 0.21, and T is 3/12. Now notice that we're told it's 3 months overdue, but T has to be in years. There are 12 months in a year, so the number of years is 3/12, or 1/4 of a year. Okay, and so we're given these values. Now we just plug those into our formula, I equals PRT, to figure out the amount of interest owed. Okay, multiplying those numbers, you get 34.13, and the conclusion therefore is that $34.13 is owed. Now one thing about these simple interest problems is the formula is also simple for simple interest, and we're going to learn one more formula. It's also a pretty simple formula. So the only tricky part about simple interest formulas are, one, remembering to use 360 days in a year if the problem is expressed in days, and the other thing is really just reading the problem and then deciding which variables or which parameters in the equation the numbers that you're given actually represent. So let's look at another example. A commercial for a loan company says you only pay 16 cents a day for each $600 borrowed. Okay, so they're trying to get you to borrow some of their money, and they don't quite want to tell you what the interest rate is, so they try to make it sound a little bit nicer by saying, hey, you only pay 16 cents a day for every $600 you borrow. Okay, so you borrow $1,800 and you borrow it for 240 days. You repay it in 240 days. So the question is, what total amount will you have to repay, and what annual interest rate is the company actually charging? Okay, so those are important questions, right? So you're 240 days, you're going to pay back the loan. You need to know how much you have to pay. Obviously you're going to pay back the $1,800 plus whatever interest is accrued. And then the question is, well, if you were to do that, what would be the interest rate? What would be the annual interest rate for this loan? Because really one of the purposes of the financial math stuff we're doing is to learn to take kind of problems like this that are expressed kind of in a weird way and compare apples to apples. So just solely on is this interest rate a better deal for me than that interest rate? And sometimes if problems aren't expressed in terms of interest rates, it's hard to tell. So one skill you want to develop is learning how to do that. All right, so let's see, $1,800 is 3 times $600. All right, so each day you pay 16 cents for each of those $600 you borrowed. You borrowed $1,800. That's 3 times 16 cents equals 48 cents per day. Okay, so your daily fee for borrowing this money is 48 cents per day. All right, you borrowed the money for 240 days, so you're going to have to pay 48 cents a day for 240 days as your interest, and that comes to $115.20 over the life of the loan. All right, so we know the interest amount we have to repay, $115.20. We know the principal, that was the amount that we borrowed, that was $1,800. And now the time period, again, T is in years in these problems, and this is a simple interest problem, so we're going to use 360 days in a year when we convert days to years. And so T is 240 over 360. Plug that into our formula. I equals PRT. So 115.20 equals 1,800 times R times 240 over 360. All right. And then plugging that into our calculator, we get R equals 0.096. And since we paid $115.20 in interest, plus our $1,800 in principal, we're going to repay a total of $1,915.20, and the annual interest rate is 9.6%. Okay? Now we want to look at another equation for simple interest, which actually doesn't just give us the interest amount. Notice that I equals PRT just told us the amount of interest we'd owe. Okay, this particular formula tells us the total amount we'd owe. So back in the previous problem, back in the previous example, there were two questions. The first question was, what's the total amount you'll repay, and what annual interest rate does that come to? Well, this formula directly gives you the total amount that you'll repay for a simple interest problem. Now usually in simple interest problems you can actually use one or the other formula. You just have to decide which one's sort of the quickest way to do it. Most problems you can solve using both ways. But you know, these formulas each have their place, and each formula is used quite often. All right, so in this formula, the total amount you'd repay if you had to pay back I equals PRT in interest is your interest I, which is PRT, plus P, your principal. So if you add the principal and the interest, you get the total amount, and if you factor out that principal amount, you get the form of the formula that we'll use it, A equals P times the quantity 1 plus RT. Okay, that's where A is the total amount. It's also called the future value. We'll use the phrase future value a lot more in the future. P is the principal, or now we'll start to also use the phrase present value. And then R is the annual simple interest rate, also again written as a decimal. And of course T is the time in years. All right, so let's see an example here of using this formula. So one common application that we'll see in the book are so-called T-bills, Treasury bills. And Treasury bills are short-term instruments that the federal government uses to help finance its debt. So I'm sure you've heard a lot about the national debt, and there are Treasury bonds and there are Treasury bills, and there are other instruments too. Treasury bills are short-term loans, so investors will buy a Treasury bill, and the idea there is that you don't get a very high interest rate on Treasury bills, but your money's really safe because the government's not going to default. Okay, now again, the key thing about these Treasury bill problems is they're not so hard to solve, but you just have to learn to identify kind of what phrases in the problem correspond to which variables in the formula. Okay, so the question is, what annual interest rate is earned by a 13-week T-bill with a maturity value of $1,000 that sells for $989.37? Okay, so the idea here is that you're going to buy this Treasury bill from the government for $989.37. All right, so 989.37 is the amount that you're going to invest. So that's going to be your P. The total amount you're going to get back is the maturity value. So the maturity value is the total amount, interest plus principal, that you earn back. And in this problem, that's $1,000. Okay, so that'll represent A. The time period's obviously 13 weeks. Okay, so we're going to have to convert 13 weeks to years. And then the question is, what is the annual interest rate? So what is R? We're being asked what R is. Okay, so this is pretty common to all T-bill problems. So in T-bill problems, P corresponds to the selling price or the purchase price of the T-bill, and A corresponds to the maturity value. Like we just said, in this problem we have P is $989.37, A is $1,000, T is 13 over 52. That's because there are 52 weeks in a year, so since it's expressed in weeks, we do 13 over 52. Now our formula is A equals P times the quantity 1 plus RT. We plug in all the values that we're given, and we just have to solve for R. All right, so I won't often do computations like this. I expect that you've got the algebra background to do that, but I'll do it this time. Many ways to solve this problem. The first thing I would do is divide both sides by 989.37. Doing so, I get 1.011 is approximately equal to 1 plus R times 13 over 52. Subtract 1 from both sides, so 0.011 is approximately equal to R times 13 over 52. So R is about 0.044, or 4.4%. Okay? So we'll see a number of these T-bill problems in your online homework, possibly in exams. Here's an interesting type of problem. It has to do with computing the actual interest rate that you earn on an investment if you take out the commissions that you have to pay to like your stockbrokers. Okay, so if you many investment firms, they charge commissions based on the amount of the transaction. Okay, so you ask your stockbroker to buy you some stock. Okay, he'll buy you some stock, but you have to pay a commission, and that commission amount is based on how much you want to buy. You want to sell your stock? Great, your stockbroker will sell it for you, but you got to pay him a commission again. All right, so with these commission-based transactions, they get you coming and going. They get you when you buy the stock, they get you when you sell the stock. Okay, so suppose a particular firm charges commissions on stock trades according to the following schedule. So if the total amount of stock that you're buying or selling is valued at under $3,000, then the commission is a flat $25 fee plus 1.8% of the transaction amount, of the principal amount. If the amount of stock that you're buying or selling is valued between $3,000 and $10,000, your commission is a flat $37 plus 1.4% of the principal amount. If the amount of stock you're buying or selling is over $10,000 in value, your commission is a flat $107 plus 0.7% of principal. Okay. So let's suppose that an investor purchases 175 shares at $15 a share. That investor holds on to that stock for 26 weeks and then sells it for $17.25 a share. So it goes up in value. He holds it for half a year. It goes up in value, and it gets to $17.25, and then he decides to sell. Okay. So the question here is find the annual interest rate earned by this investment. Okay. So we'll do this in a few steps here. So the first step is we're going to find the total cost of the purchase. All right. Well, on the one hand, the investor wants to buy 175 shares of stock. Each share of stock costs $15. All right. So he's going to have to pay $2,625 just for the stock. All right. So again, he goes to the stockbroker, says, I want to buy 175 shares of company XYZ, it's $15 a share. Great, that's going to cost you $2,625 just for the stock. But to get the stockbroker to do it for you, he's going to charge you commission. That's going to add on commission. Okay, so it's going to cost the investor more out of pocket. Well, how much more? All right. Well, that $2,625 is under $3,000. For transactions of under $3,000, the commission is a flat $25 fee plus 1.8% of principal. So the commission comes to 25 plus 2,625 times 0.018, and that comes to $72.25 commission. All right. So in order for the stockbroker to buy that stock for you, you're going to have to give him the money for the stock, the 2,625, and you're going to have to give him the money for the commission, the $72.25. All right. So the total cost of the purchase comes to $2,625 plus $72.25, and that comes to $2,697.25. That's the total cost of your purchase. Now let's find the net revenue from the sale. All right. So the sale, it's now 26 weeks later, and the value of the stock has gone up to $17.25. Okay. So the customer can't sell the stock himself. He's got to ask the stockbroker to do it. So he says to the stockbroker, "Sell my stock." Okay. The stockbroker sells it. Now it's worth $17.25. Those 175 shares are worth $17.25 each. So the amount of money you get back from the stock is $3,018.75. That's your principal amount. All right. But now every time you ask that broker to do something for you, they charge a commission. Okay. So now the principal amount is over $3,000. So the commission schedule says that you've got to pay $37 plus 1.4% of principal. All right, so that's $37 plus 1.4% of $3,018.75. That comes to $79.26 in commission. All right. Now, what happens to the commission at the time of the sale? Well, when we bought the stock, you had to add the commission onto the amount of money you gave to the broker. Okay, you paid for your stock and you paid for your broker. All right. Now, when the money's coming out of the stock market, you're going to get your money back from the stock, but your broker's going to take his cut. So you're going to get back your $3,018.75, but right before your broker gives it to you, he or she is going to take out that $79.26. So at the time of the sale, you have to subtract the commission from the principal in order to determine how much the net revenue is from the sale. All right. So that's $3,018.75 minus $79.26. That comes to $2,939.49. That's the net revenue from the sale. Okay. Now we've got the information we need to calculate the annual interest rate. That's what we want to figure out. All right, was this a good investment or was it not a good investment? To figure that out, we need to know the annual interest rate. Okay, now remember, at the time of the sale, the amount we got back was $2,939.49. The principal amount was $2,697.25. That's how much money we had to spend to buy the stock. So to buy the stock, we had to pay $2,697.25, principal plus commission. When we sold the stock, we got back $2,939.49. Okay, so P is the amount we invested, A is the amount we got back. The time period in years is 26 over 52, or 1/2. It's 26 weeks. There are 52 weeks in a year, so we convert that to years, we get 1/2. Our formula is A equals P times the quantity 1 plus RT. Why are we using that formula? Because we have a total amount given in the problem. Okay, so that's $2,939.49 is equal to $2,697.25 times a quantity 1 plus R times 0.5. R then comes to 0.1796. Okay, so the interest rate from that investment for that investor was 17.96%. Okay, let's look at another example. Let's suppose that after buying a new car, you decide to sell your old car to a friend. All right. Now your friend can't quite pay you right now. Your friend can't pay you right now, but says he or she can pay you 270 days from now. All right. So you accept kind of a contract or note, a 270-day note. Basically a note that says your friend's going to pay you in 270 days. All right. Now you could sell the car now, but your friend wants to wait 270 days to give you the money, wants the car now. So you're going to charge some interest. All right. So the car is valued at $3,500. That's how much you're selling the car for. And you're going to charge your friend 10% simple interest for the privilege of not having to pay you for 270 days. Okay. At the end of that time, at the end of the 270 days, the principal and the interest will be paid at that time. All right. So you've got your friend gives you this note of guarantee that he's going to pay you, drives off with the car. Okay. You don't have any money yet. But it so happens that 60 days later, you find that you need the money. Okay. You were selling the car. Maybe you want to buy a new car. You've got to make a down payment. You need that money. All right. So what happens? What can you do? Well, this happens all the time in the financial world. Somebody guarantees somebody a payment at some point in the future. Well, that contract is transferable. So you want to transfer that contract to somebody else. All right. Now, what you do is you sell that note to a third party. So you sell the note to somebody. That means that when your friend comes back to pay, he's going to pay the person you sold the note to. All right. Now, some interest is already accrued. You sell the note for $3,550. Okay. The question then is, what annual interest rate does the third party receive for the investment? All right. So the third party is actually not going to get 10% simple interest. He's going to get a little bit more, a little bit less. We'll see why. Okay. So originally, how much would your friend have to pay you at the end of that 270 days? Well, A equals P times 1 plus RT. That's 3,500 times a quantity 1 plus 0.1 times 270 over 360. That comes to $3,762.50. Okay, so that's what your friend was going to have to pay you at the end of that 270 days. Now, for the third party, we're going to find the annual rate of interest R required to make his investment of $3,550 grow to $3,762.50. Okay, so that third party, your investment amount would have been $3,500, but the third party bought that note for $3,550. That's the third party's P. What's the third party's A? Same as your A. You or the third party would have gotten back the $3,762.50. It's just you invested different amounts. There's also different time periods for you versus the third party. You were going to get paid after 270 days of holding the note. That third party, he bought it 60 days after you. He's going to get interest over 210 days. So 270 minus 60. All right. So we need to find the interest rate R, the new interest rate R, given that A is 3,762.50, P is 3,550, T is 210 over 360, what's R? Okay, now your R, as the original person who made the deal, your R would have been 10%. Let's see what the third party's R is with the different P and the different T. The investment amount A, or the total amount A, was $3,762.50. The amount invested by the third party was $3,550. Multiply that times the quantity 1 plus R times 210 over 360. Solve for R, we get 10.262%. Okay, so the idea is, why is that third party getting a higher interest rate than you? Right? It's the same note. Right, it's the same note, but that $50 was actually, you were selling it under value. So that note was worth a certain amount after 60 days. And if you had sold it for that amount, the third party would have gotten 10% back. But you didn't sell it for that amount. You sold it for slightly less than it was worth. So since you sold it for slightly less than it was worth, that third party gets a slightly higher interest rate, slightly higher return on investment of 10.262%. Okay, let's look at another example. In this example, and this is actually a pretty common arrangement around tax time. Many tax preparation firms offer their clients what's called a refund anticipation loan. Okay, the idea is that for a fee, the tax firm will give the client the refund when the return is filed. So you'll immediately get your refund from the tax preparation firm. Okay. Now, in reality, you file your taxes, you don't get your refund immediately. You have to wait till the IRS approves it. Then they get around to sending it to you. If you do it electronically, if you do it through direct deposit, you get it more quickly, but you don't get it immediately. All right. With this arrangement with your tax preparation firm, they're going to give it to you immediately. All right, but for a cost. So in a sense, if you're getting a tax refund of, let's say, $1,000, they'll give you that $1,000 now. All right, but why? Because they're going to charge you for that. So they're going to charge you a fee for that, and then they're essentially giving you a loan of $1,000 that you're going to pay back when you get the tax refund. Except they're not going to pay you the tax refund. It's just the IRS is going to pay it off for you by directly paying the tax preparation firm that refund. Okay, so it's like, you know, you're going to get $1,000 pretty soon. So you borrow $1,000 from the tax preparation firm. They charge you some kind of fee, and the loan is satisfied when that refund comes in to the firm. Okay, so the question is, you know, these refund anticipation loans, they look like pretty low fees. What does that actually come to in terms of an interest rate? Is it really a good loan or not a good loan? Okay, so for a fee, the firm will give the client his refund when the return is filed. The loan is repaid when the IRS sends the refund directly to the firm. Okay, so the RAL fee, the refund anticipation loan fee, is equivalent to the interest charge for the loan. Let's say there's a lender, major RAL lender, with the following fee schedule. If your tax return amount is between $0 and $500, the fee is $29. $501 to $1,000, the fee is $39. $1,001 to $1,500, the fee is $49. $1,501 up to $2,000, that fee is $69. $2,001 up to $2,500 for a tax refund amount, the fee for a refund anticipation loan is $89. Okay, so let's say they do your taxes. You're going to get a refund of $480, and you want it now. You don't know when the IRS is going to give you your refund. It might be soon, might be later, but you want your money now, so you take a refund anticipation loan. Okay, now that fee, you can see from the fee schedule there, is going to be $29. Seems pretty reasonable, all right? Now let's say the IRS paid back that refund in 25 days, all right? The question then is, what is the annual interest rate for that loan? So what annual interest rate does that come to? And it's a pretty interesting result. All right. So P, the principal amount, is $480. Okay, according to the schedule, like we said, the interest amount charged is $29. It's 25 days later, so the time in years is 25 over 360. So we now compute R. Notice that there's no total amount here, so we could use the A equals P times 1 plus RT formula, but actually this problem, even though it's kind of a long statement of a problem, actually we can use the I equals PRT formula. Okay, so let's compute R. I equals PRT. So 29 equals 480 times R times 25 over 360. And calculate R. Look at that. We get R equals 0.87. So that means that $29 over 25 days, that amounts to an 87% interest rate. 87%. See, the key is that interest, really the interest rate depends on not just the amount of the loan and the bare amount of the loan and the bare amount of the interest paid, the actual amounts, but also depends on the time period. And interest rates are relative; they're percentages. Okay, they're relative to the size of the loan, they're relative to the time period. And if you calculate out here, you get an 87% interest rate. So it would have seemed, you know, not too bad a deal. But if you look at it like that, with sort of, you know, apples to apples comparisons with other loans, 87% is a really terrible financial decision. Okay, so this is an introduction to simple interest. We've got two formulas: I equals PRT, A equals P times 1 plus RT. Usually, one or the other formula is better to use in a problem, but often either one could be used. The other key thing to remember is that when you're converting a number of days to a number of years, use that conversion factor of 360 rather than 365. So you should start practicing these problems, looking at the online homework. It's important that you get used to the various types of applications of simple interest that you see in the book and in the online homework. Again, the problems aren't that hard. The real trick is just learning to identify in each type of problem what's A, what's P, what's I, what's R, what's T, how do I convert that. Once you get that down, you'll have no problem with this section. That's all.